You're a great white shark, and you've just spotted the largest animal to ever exist on this planet, larger than any dinosaur that ever walked the earth. Every instinct says predator sees prey, sizes it up, moves in. But something in the water stops you cold before you even get close. The blue whale isn't just big. It's something the entire ocean has learned, generation after generation, to actively avoid. Here's the rule every animal in the ocean lives by. Run from the things trying to kill you. But the single most dangerous thing in the water doesn't have teeth. It doesn't hunt you. It doesn't chase you. It genuinely doesn't know you exist. And even killer whales, the ocean's most feared hunters, won't touch a healthy adult blue whale. Not because they're being cautious, because they're outmatched. And not just by muscle, by something closer to raw physics. So how does an animal with no weapons at all become the single thing every predator in the ocean is quietly afraid of? Let's actually work through it, piece by piece. Before we even get to the physics, it's worth sitting with just how recent our understanding of this animal actually is. For most of human history, nobody had any real sense of what a blue whale's life even looked like beneath the surface, because nobody could follow one down there. That changed dramatically only in the last few decades. Once biologging tags, suction-cupped instruments packed with sensors, cameras, and hydrophones could actually be attached directly to a living whale and left to record as it dove, fed, and called out into open water. Almost everything genuinely surprising about this animal, the exact mechanics of its lunge, the true intensity of its call, the astonishing behavior of its heart, has only been directly measured within roughly the last 15 years. We spent longer studying the surface of the moon in detail than we spent actually recording what happens inside a blue whale's chest. Start with the number that makes everything else make sense. A fully grown blue whale weighs around 400,000 pounds. That's roughly the mass of 33 adult elephants, or a fully loaded commercial airliner compressed into one living body. And this isn't an animal that just drifts. Blue whales can accelerate to speeds of around 20 miles per hour in short bursts, and some tagging studies have recorded brief spikes even higher. Put 400,000 pounds of muscle into motion at that speed, and you're not looking at an animal anymore. You're looking at momentum in the purest physical sense, and momentum doesn't care whether it means to hurt you. Here's the thing nobody tells you about what that actually does to the water around it. A blue whale doesn't have to attack anything to be dangerous. Its wake alone, the turbulence trailing behind a sprinting whale that size, is powerful enough to violently spin smaller animals off course. Marine biologists studying whale hydrodynamics have documented exactly how much displaced water a body this size generates in motion. And the short version is that anything caught in that slipstream, a dolphin, a shark, a diver, gets thrown around like it's caught in a rip current with no warning. It's the underwater equivalent of standing at the edge of a highway when a fully loaded freight truck blows past at speed, except the air is water, roughly 800 times denser, and the truck weighs as much as a small apartment building. Now here's where it gets interesting, because that's just the whale existing. Feeding is a different category of violence entirely. Blue whales don't graze. They use a method called lunge-feeding, and biomechanics researcher Jeremy Goldbogen at Stanford University has spent years using suction cup biologging tags to record exactly what happens during one. A blue whale locates a dense swarm of krill, dives, orients itself, and then accelerates directly toward the densest part of the swarm at close to full speed. Right before impact, it drops its lower jaw open. That jaw isn't rigid the way most animals' jaws are. The underside of a blue whale's throat is covered in accordion-like grooves called ventral pleats, and Goldbogen's research has shown they can expand dramatically, ballooning the mouth cavity outward like a parachute catching wind. In a matter of seconds, the whale engulfs a volume of water and krill roughly equal to its own body weight. A swimming pool's worth of ocean swallowed in a single, controlled lunge. To a swarm of krill, there's no chase. There's just an instantaneous wall of water that erases their entire patch of sea. So what would actually happen to something that got caught inside that lunge? Say you're a scuba diver, in exactly the wrong place at exactly the wrong moment, and the water around you suddenly accelerates, goes dark, and you realize you've been engulfed. Are you in trouble? Surprisingly, less than you'd think. Inside that mouth, you'd be sitting in total darkness, surrounded by thousands of gallons of water and a great deal of extremely confused krill, trapped behind a curtain of baleen plates. But you wouldn't be eaten. Despite a mouth cavity large enough to swallow a small vehicle, a blue whale's actual throat is famously narrow, roughly the diameter of a grapefruit, built by millions of years of evolution to process enormous volumes of tiny prey, not a single large object. Marine biologists have long used exactly this detail to explain why the popular image of a whale swallowing a person, going all the way back to old maritime folklore, is anatomically impossible for a blue whale. The whale would register an object that clearly isn't krill, and it would simply reopen its mouth and flush the water and you back out. Traumatic, not fatal. But here's the thing nobody tells you. If you're swimming near a blue whale, getting engulfed isn't actually the biggest risk. Something you can't even see is. Blue whales are loud in a way that barely fits ordinary description. Their low-frequency calls have been recorded reaching around 188 decibels underwater, among the loudest sounds produced by any living animal on Earth. For comparison, a jet engine at takeoff measures around 140 decibels in air, loud enough to permanently damage unprotected human hearing at close range. Water is roughly 800 times denser than air, which means sound doesn't just travel faster through it, it transfers dramatically more physical energy on contact. A call at 188 decibels underwater isn't just loud, it's a genuine pressure wave. Researchers studying underwater bioacoustics have noted that sound at that intensity at close range carries enough physical force to be felt as vibration through soft tissue, not just heard. Here's the thing nobody tells you about what that does to everything else living down there. In the deep ocean, where light barely penetrates, animals like sperm whales and dolphins depend almost entirely on echolocation, sending out clicks and reading the returning echoes to build a working mental map of their surroundings. When a blue whale calls at close range and full volume, that acoustic map gets overwhelmed instantly. Researchers studying acoustic masking in marine mammals have documented how loud, low-frequency noise can functionally blind echolocating species to their surroundings for a period afterward, disrupting navigation and group communication. To a sperm whale caught nearby, a blue whale's call functions almost like a flashbang, disorienting, involuntary, and forcing an immediate retreat just to recover basic spatial awareness. So if you can't even safely be near this animal, how does anything actually hunt it? The honest answer is almost nothing does, and the anatomy explains exactly why. A great white shark looks, on paper, like a plausible threat. It's an ambush predator with a genuinely fearsome bite, but a great white's teeth measure roughly 2 to 3 inches. A blue whale's blubber layer runs well over a foot thick in places, bite as hard as a great white physically can, and those teeth simply don't reach anything vital. No artery, no organ, nothing but dense fat and muscle. It's a catastrophic waste of energy for the shark, and the only thing it accomplishes is irritating an animal roughly the length of 3 school buses. And irritating a blue whale carries a specific, well-documented risk: the tail. A blue whale's flukes can span up to 25 feet across, roughly the width of a 2-car garage, and they're driven by the peduncle, the single densest, most heavily muscled section of the whale's entire body. The whale doesn't need to outmaneuver a predator or bite it, it only needs to swing. Marine researchers studying large whale defensive behavior have documented cases of humpback and other large whales using tail strikes forceful enough to launch orcas partially clear of the water. Applied to a shark, that kind of force is more than capable of shattering cartilage and snapping a spine outright. An animal with no offensive weapons at all turns out to have one of the single most devastating defensive strikes in the entire ocean. Which brings us to the one predator that actually does hunt blue whales, under very specific conditions: orcas. A single orca, or even a small hunting pod, has effectively zero chance against a healthy adult blue whale, so orcas don't try. Documented predation events, including well-studied cases off the coast of Western Australia, involve coordinated superpods, sometimes 50 to 70 orcas working together continuously for hours, targeting calves rather than adults. Because the calf's blubber is still too thick to bite through effectively, the orcas instead use an exhausting, physically brutal tactic: taking turns swimming over the calf's blowhole, repeatedly forcing it underwater to prevent it from surfacing to breathe. It's less an attack than a coordinated war of attrition. And if the mother manages to land even one solid tail strike during the encounter, an attacking orca can be killed outright. The fact that it takes dozens of the ocean's most intelligent, most coordinated predators several grueling hours just to bring down a single calf tells you everything about why nobody even attempts it against a full-grown adult. Now here's where it gets interesting again, because you might reasonably ask whether anything in Earth's history could have taken one down. What about Megalodon, the 50-foot prehistoric shark whose entire evolutionary niche was hunting whales? Here's the problem. Megalodon averaged around 50 feet in length. A blue whale approaches 100 feet and carries nearly triple the mass. Megalodon evolved to hunt the baleen whales of its own era, which were considerably smaller than a modern blue whale. Even with dramatically larger jaws and teeth than any living shark, Megalodon would run into the exact same anatomical wall a great white does today, just delivered with more damage per bite. It could tear away a genuinely significant chunk of blubber and muscle, but it still couldn't reach anything vital on an animal this scaled up, and a single well-placed 25-foot tail strike to the skull would very plausibly be fatal even to an apex predator that size. In a direct, close-range confrontation, raw mass still wins. So here's the actual puzzle worth sitting with. If becoming this enormous makes you functionally untouchable by the most dangerous predator in the history of the planet, why didn't more animals do exactly this? Evolution usually runs as an arms race. Predators get faster, so prey gets better at evading. Predators get sharper teeth, so prey grows thicker armor, or camouflage. It's an endless back and forth. The ancestors of the blue whale essentially opted out of that entire game. Rather than compete on speed, defense, or evasion, they found an enormous, nutrient-dense, virtually uncontested food source, krill, and simply scaled their bodies upward to exploit it at a volume nothing else could match, aided by the fact that water itself supports body mass in a way gravity on land never could. No venom, no armor, no camouflage, just size applied at a scale that quietly removed them from the category of prey entirely. You cannot effectively hunt something that nothing alive can fit its mouth around. So if getting bigger solves nearly every problem in the ocean, why stop around 100 feet? Why not 200? Because biology hits a hard physical ceiling, and that ceiling is the heart. In a landmark 2019 study published in the Proceedings of the National Academy of Sciences, Jeremy Goldbogen's research team successfully attached a biologging tag directly to a wild blue whale's heart region and recorded for the first time its actual heart rate in real time. At rest during a deep dive, the whale's heart slowed to roughly 2 beats per minute, an almost eerie stillness for an organ the size of a small car, weighing somewhere around 400 pounds. But during a lunge-feeding event, the moment the whale accelerates and its jaw opens to engulf that swimming pool volume of water, the recorded heart rate spiked to around 37 beats per minute, roughly double what the researchers had predicted using standard physiological scaling models. That's not a leisurely pace. For a heart this size, the study's authors concluded, that spike represents the animal operating extremely close to its absolute cardiovascular limit. The team's modeling suggested blue whales may already be pushing up against the outer physical boundary of how large a lunge-feeding, warm-blooded animal's circulatory system can plausibly get. Scale the body up much further, and the energetic cost of a single lunge feed could plausibly outstrip what any heart, no matter how well engineered, could physically sustain. Here's the thing, nobody tells you about how the rest of the ocean actually perceives an animal at that scale. And it isn't really about sight at all. We understand blue whales as large because we can see satellite images, full-body photographs, scale comparisons. Most fish and sharks don't have that luxury. They rely heavily on the lateral line, a sensory system running along their bodies that detects pressure changes and water displacement. A normal-sized predator swimming past registers as a localized, identifiable disturbance. A 400,000-pound blue whale approaching registers as something else entirely, an overwhelming, directionless surge closer to feeling the ocean itself begin to move. Researchers studying lateral line sensitivity in fish have noted that at a large enough displacement volume, that system doesn't return useful information about an animal. It just returns danger, undirected and total. And the appropriate response to that signal is simply to leave immediately without waiting to identify the source. Here's the thing nobody tells you though, and it's genuinely one of the strangest contradictions in the entire ocean. For all this documented power, the blue whale is also one of the most vulnerable large animals alive, and the thing it can't outscale is us. Commercial whaling through the 19th and 20th centuries, once explosive harpoon technology made it physically possible to kill an animal this size at all, drove the global blue whale population down from an estimated few hundred thousand individuals to as few as several thousand by the time the International Whaling Commission finally banned commercial blue whale hunting in 1966. An animal that nothing in the ocean can safely challenge turned out to have no evolved defense whatsoever, against a weapon it had never encountered across its entire evolutionary history. Populations are slowly recovering in some regions today, but blue whales remain listed as endangered, and modern threats, ship strikes from large cargo vessels, and entanglement in fishing gear chief among them, kill more blue whales today than any natural predator ever has or likely ever will. It's a genuinely strange kind of irony. An animal engineered by millions of years of evolution to be functionally unkillable by anything in its own ecosystem, brought to the edge of extinction almost entirely by something that isn't part of that ecosystem at all. There's one more detail worth knowing, because it connects directly back to that 188 decibel call. Researchers who have tracked blue whale vocalizations across multiple ocean basins over several decades have documented something genuinely strange. The pitch of blue whale songs has been gradually, measurably dropping year over year across populations worldwide. Several proposed explanations exist, including the theory that as whaling-era population densities were slowly rebuilt, whales no longer needed to call as loudly or as high-pitched to be heard across the same distances, since their populations were spread out differently across recovering numbers. Nobody has fully settled the explanation, but the pattern itself is remarkable. An entire species' voice, gradually shifting, generation after generation, in a shift so slow it can only be detected by comparing recordings separated by years. Put all of this together, and the blue whale stops fitting into either of the two boxes we usually sort animals into. It isn't a gentle giant. Not really. Not when it can annihilate a patch of ocean in a single coordinated lunge or generate a call powerful enough to physically disorient an echolocating predator from a distance. And it isn't a predator either, since it has functionally zero interest in hunting anything larger than the width of a fingernail. It exists somewhere the rest of the food chain was never designed to categorize. An animal so overwhelmingly scaled, that the entire concept of predator and prey simply stops applying to it. It's also worth remembering that a blue whale doesn't experience any of this as intimidation, because it isn't doing any of it on purpose. It has no concept that a shark is giving it space, no awareness that a sperm whale just fled its acoustic range, no understanding that its own wake could snap a rib. It's simply going about the single, narrow task its entire biology has been optimized around for millions of years: finding krill, engulfing krill, and diving again. Every ounce of the fear it inspires is a byproduct, not a strategy. In a sense, that makes it even stranger. Most of the ocean's most feared animals, orcas, great whites, earned that reputation through deliberate, targeted violence. The blue whale earned an equivalent reputation purely through scale, without a single hostile intention behind it, which might be the single strangest kind of power in the entire animal kingdom. Total dominance, achieved entirely by accident. So picture that great white shark again, drifting at a careful distance, watching the largest animal to ever exist move slowly through open water. It isn't circling, it isn't testing the water for an opening. It has already run the calculation every predator in that ocean has learned to run, across millions of years and countless generations. You don't fight something this disproportionately powerful, and you don't try to intimidate it either. You simply acknowledge it, give it the room it requires, and let the largest animal in the history of life on Earth pass by, entirely unaware that anything was ever afraid of it at all.